Hello, everybody, and welcome to this episode of the Ampere Developer Impact. I'm joined today by Luca Guerra, who's a senior open source engineer for Sysdig and a core contributor to the Falco project. Luca, welcome.
Thank you, Dave.
Well, thank you for joining me. Today, we're going to talk about the Falco project, what it is, the value it brings to cloud-native application developers, and especially Kubernetes cluster administrators, how you use it, what it does, around how the Falco project has been working with Ampere around ARM64 support. So Luca, just to get us started, can you tell me a little bit about the project? Tell me about Falco. Where did it come from? Why is Sysdig investing in it?
Yeah, Falco was originally created by Sysdig and then donated to the Cloud Native Computing Foundation. It's been adopted so much that it's now a graduated project since last year. And what Falco does is acting like a security camera for your hosts, cloud, and application. Pretty much, Falco detects security relevant events. Falco detects what you are interested in. Falco detects suspicious events and can be used for security monitoring, security auditing, and also for regulatory compliance, because some regulation require you to actually monitor for specific events. So what Falco can do is alert you about everything. And it has a lot of add-ons and a lot of applications that interact with it that you can use for many other use cases.
Okay. Well, you've described what it does, right? It provides compliance. It provides information for compliance. It provides information for cluster administrations when suspicious activity happens. Who's the target audience of it? Is it container application developers or is it cluster administrators?
It is normally cluster administrators and security teams.
Okay. And can you talk me through how they would use it?
So the way you use Falco is you can use it on a lot of different systems. So you can use it on bare metal nodes and you can use it on clusters, Kubernetes clusters, and on pretty much every major cloud provider. So installing Falco for the first time is very, very simple. So if you have a Kubernetes cluster, we provide a Helm chart that you can, with pretty much a single command, you can use it to get started. The Helm chart does a lot of cool things around under the hood, and it will set up Falco on all your nodes. And after that, if you follow this guide that you can find on the Falco website, you can see that in just a minute, Falco will be up and running. And if you follow the tutorial, if you could please scroll down a little, we can show that it's very easy to trigger a rule to show that Falco can detect any suspicious activity. So in this example, if you, on the same cluster, would run a command to read a shadow file, which is usually used to contain password and not accessed by most applications, Falco will immediately trigger an alert and it will show it directly on your Kubernetes log. And it doesn't stop there because, of course, Falco integrates with your existing monitoring solution, if you have any, or your existing log aggregator, so you can configure it to ship the log anywhere where it's most comfortable for your team. And also, Falco comes with many rules pre-configured that we'll also take a look at, but you have the power of creating any rule that you want to monitor every possible system call or event, even in your cloud provider or at the cluster level. So in this case, there is a very simple example which is very easy to understand. The rule language is designed to be easy to write for people that are developer or cluster operators or security expert, and doesn't require you to be a kernel expert or have some very specialized knowledge.
Well, let me try and parse this one. So what this is saying is if you get an open attempt on and it's opening for a write, and it's a file type, and the file descriptor is greater than 0, so you're not writing to standard out, and it starts with etc., then log an event, right? So this is anytime anybody tries to write to any configuration file under /etc, you get an event. Is that right?
Absolutely correct. As you can see, this is the first time you saw that rule and you immediately understood what it did. But you don't have to write your own rules. If you, we have a list of rules that are shipped with Falco, and also you can load from our open source repositories, and there's more than 200 rules in our community managed open source repository. And as you can see here, we have some very cool things that are detected. This one is loaded by default. If you don't do anything, this already appears. And this is very important. A lot of security teams really like this specific rule because it will alert you whenever a new binary that wasn't present in an image, in a container image, gets written and executed inside the container. So this can be a very strong signal for a potential attack attempt, or for some operation that is usually not allowed by security teams, mostly because container images are supposed to be immutable. So having an alert on this operation will help you understand which images are not immutable or might be attacked. And like this, there's so many rules that you can take a look, that you can customize, enable or disable, or do everything as you want for your own needs.
Okay. Well, thank you very much. So we talked about what it does. Falco enforces security standards and logs any events that you've configured to flag for. Can you tell me a little bit about how it does it?
Oh, yeah, sure. So Falco, when Falco is used on hosts and on clusters, it interacts with the Linux kernel. So it interacts at a very low level using either a kernel module or an eBPF probe. You can choose, depending on your system, you might want to use a kernel module, or you might want to use an eBPF probe, but by default, Falco will try to figure out which one you need automatically. And that's very cool because it does it even if your cluster is made up of several different nodes with different architectures. So you might have x86 and ARM, maybe from Ampere, and Falco will automatically install the appropriate module or eBPF probe for your system. Once that's installed, all the events are read and processed by Falco. They are sent to the main Falco process, and for each one, the rules are evaluated, and you will only get the ones that you're interested in, thanks to the rule that you configured.
Okay. Well, eBPF, so my memory on this is a little shady, but eBPF is the extended Berkeley packet filter. It came from the network world. How does that interact with things like Kubernetes events? You know, running a container in a Docker, running a file in a Docker container.
So that's a very nice development of the Linux kernel that we've seen happening in the last few years. So eBPF is a technology that, of course, started with network, but today allows you to write programs that run inside your Linux kernel, and it uses a specific language with a specific bytecode that has a few very nice advantages. One is the fact that it's safer than running a kernel module directly compiled from any arbitrary code, because the language is restricted in such a way that it's very, very hard to bring down a kernel or create a kernel panic or have some very bad performance issue in a production system, which is a feature that we as developers like a lot, because we are a bit happier that our system is probably not going to create so much damage like a bug in a kernel module can create. So that's great for us developers. Of course, you can somehow mess up with the eBPF, because if you give a developer enough time, they will be able to. But it's much harder and it's much safer. And on the other hand, thanks to recent advancement with eBPF, you can load eBPF probes on a vast array of kernel versions without having to recompile having to recompile them. This is great because kernel modules need to be compiled for each and every specific version, and that's of course we do it for hundreds and hundreds of kernels, but it's it's a lot of work to have it compatible with many different systems that are the systems that people actually use in production. Right. So you want your system to work, and eBPF makes it a little bit easier to do so. On the flip side, all the features that we use are supported on only a fraction of the Linux kernels that people use. So it's great that Falco has options to run both kernel module or eBPF.
Okay. So you talked about Falco works with ARM64, runs on Ampere hosts. Can you talk a little bit about how Falco and Ampere have worked together over the last few years, and what's the state of ARM64 support for Falco? How has it developed over the last 2-3 years?
So about a couple years ago, I think almost 3 years ago, we started a project within Falco to actually support ARM64. There was a lot of interest from the community, and some people actually built their own experimental versions of Falco for ARM64. But there was no officially supported distribution. So we actually made it. We made the entire code base compile fine directly from our main open source repositories for ARM64. And but the one thing that Ampere has helped with is the fact that at the beginning we didn't have much resources to actually run our CI/CD pipelines on ARM64, because we only had a few free credits from a CI system that we no longer use. And so we couldn't run our entire test suite on ARM64. And this is, of course, not a good development practice, and not, generally speaking, having developer manually run tests on several architectures is not a great use of time. So
this was the 2023-24 pilot that we ran with Actuated and Equinix, is that correct?
Yeah, that's correct.
So after using this this pilot from Ampere, Actuated, and Equinix, what is the state of ARM64 support for Falco now?
ARM64 support is pretty much a first-class citizen on Falco right now, so we think the support is stable, and people are using this version. This is something that we're very proud of, and also not just because we can reach out to more users, but also because the testing that we do is good enough that we're able to catch bugs that happen only on specific architectures, and so this helps us a lot making our own code more robust. As you probably know, if you've ever written C and C++, testing it on a single architecture and on a single type of system means that you might think that the code is actually doing what you think it does, but instead is actually working only because of some specific implementation details of an architecture. If you run it on multiple architectures and you see a failure that you don't see in any other architecture, you will probably understand that your code isn't portable, and so you can make a better patch if you need.
This is actually something we've heard from other projects as well, is that, for example, certain race conditions or certain x86 related assumptions that are made by developers are exposed when you're testing on multiple platforms, and actually make the project better for everyone. It's a really great thing to see. I was actually going to ask what language runtimes Falco is written in. It sounds like everything is C. Is that correct?
It is not. So Falco itself, the core of it is written in C and C++. But Falco has a plugin system which has seen a lot more features in the last couple of years that allows you to write plugins that are very powerful, can create new events, plugins that can analyze, that can deeper analyze existing events and then can do a lot of stuff in C, C++, Go, and Rust. So
nice.
We are now open to Rust development. I personally wrote a nice Rust plugin, and it was fun. So I'm sure that other people in the community will agree.
So traditionally, C, C++ as the core languages, those are the languages that are closer to the hardware in some sense. And so platform migration is a little bit more complicated in many cases. Can you describe how hard was the process of porting Falco to ARM64 in your initial work on it in 2022, 23?
It was definitely something that took months of development because we had to thoroughly test many things, and we had to really clean up our code base from many things that weren't portable. And we found out about a lot of things just by working on it. So, for instance, there is a difference from how variadic arguments are interpreted in the two architectures, and then you have to read the C standard to actually understand what you're doing. So it was a challenging work, and we ended up with a much better Falco after it.
Okay. And what are you using for CI today?
Today we're using everything is hosted on GitHub, and everything is open source, of course. So GitHub Actions is our main CI driver. We also have some jobs that run on Prow, which is the infrastructure that also powers Kubernetes project CI/CD.
So you're using the GitHub hosted ARM64 runners.
Yes.
Okay, and that gives you the ability to do kernel and eBPF probe testing as well.
Yes.
Okay. Can you tell me a little bit about? Obviously, you've done the work to port it to ARM64 because you had end users who were asking for it. Can you tell me a little bit about how end users have received Falco on ARM64? What do you know about how people are using it? Are people happy with it?
So at the beginning, we have seen people trying to do their own experimental builds before we wrote official support, and those people back then were working on for companies like Cloudflare or Snap. And if you go on their website, you can see that they were using ARM64 on a lot of machines because of better efficiency, because of less energy consumption, and they were actually enjoying this architecture and this type of computation. Since then, of course, we are an open source project. We do not have a customer list, so we don't know exactly who uses Falco, and that's perfectly fine for us. But we know that people are using it on ARM64 because the way every developer knows that something that people are using their software, if something breaks, we'll know it. So people are, and of course there are very nice people that contribute to our community with bug reports, and they work with us to try to get everything fixed, and we are very grateful for that. People are super nice, even when things don't work. We love that about open source and the job we do.
Yeah, me too. And it's one of those things that's quite surprising for people who aren't involved in open sources. Bug reports are a good thing. It means people are using your software. It means they're exploring the edge cases that maybe you haven't covered in your CI testing. It makes the project better for everyone. Well, Luca, what's next for Falco? Like, what do you have coming up in the next year that you're excited about?
There's so many great things that are happening within the Falco ecosystem. You might have heard of the plugin system from me just a few minutes ago, and we have so many ideas for new plugins, new detection capabilities, new cloud systems to support, and we are having a lot of ideas coming in from the community and from people that are contributing. But that's not just that. We have had a new project coming just a month ago, I think, in the Falco community, that is an integration with Wireshark that's called Stratoshark. It's a way to display the system call events that are run by Falco, that are examined by Falco in the Wireshark interface. And that, I think, is very exciting. Is something that a lot of security folks, such as myself, can be interested in. And in the Falco ecosystem, we even had a response engine recently that's called Falco Talon, that's been built still also a few months ago, that allows you to respond after you detected an event. So, for example, you can specify some operation in a Kubernetes cluster that you want to execute after a specific event is triggered. And that's something that has a lot of potential, that people are excited about, and we can't wait to see what the community will do with it. And there's so many improvements and a lot of performance improvements and detection features that we're working on, that we're very happy about.
Well, thank you very much for joining me today, Luca. This has been a great pleasure. So to summarize, Falco is a really important project in the cloud native ecosystem. It is what allows you to monitor your system and be aware of security events that are happening, and then, act on them afterwards. It's been a real pleasure to work with you over the past few months, and we look forward to talking to you again very soon.
Absolutely. It was a pleasure. Thank you so much, Dave.
Thank you.